Let's see parts of staircase. Tread. The tread is the horizontal part of the step where the foot is placed. It determines the comfort and safety of walking on stairs. Riser. The riser is the vertical portion between two treads. It gives height to each step and supports the tread above. Rise. Rise is the vertical height from one tread to the next. It determines how steep the staircase is. Run. Run is the horizontal distance covered by the staircase. It determines how much floor space the staircase occupies. Nosing. Nosing is the projecting edge of the tread beyond the riser. It increases the usable tread space and improves safety. Main functions of nosing. Increases tread space. The projection provides extra foot space without increasing the total stair run. Improves safety. It gives better grip and visibility, especially when finished with anti-slip material. Enhances comfort. The slight curve or rounded edge makes stepping more comfortable. Aesthetic appeal. It gives a finished and elegant look to the staircase. The newel post is the large vertical post at the start and end of the staircase. It provides main structural support to the handrail system. It is usually thicker and stronger than balusters. Increases tread space. The projection provides extra foot space without increasing the total stair run. Improves safety. It gives better grip and visibility, especially when finished with anti-slip material. Enhances comfort. The slight curve or rounded edge makes stepping more comfortable. Aesthetic appeal. It gives a finished and elegant look to the staircase. Handrail. The handrail is the sloping horizontal member fixed on top of the balusters. It provides support for the hand while climbing or descending the stairs. It improves both safety and comfort. The newel cap is the decorative top portion fixed on the newel post. It enhances the aesthetic appearance of the staircase. In this slide, we see how to calculate the number of steps required for a staircase. The formula is very simple. Number of steps equals the total floor height in inches divided by the riser height in inches. The standard riser height is ideally 7 inches. However, it can range between 6.5 inches to 7.5 inches depending on design and comfort requirements. For example, if the total floor height is 10 feet 0 inches, we first convert it into inches. 10 feet equals 120 inches. In this example, the total floor height is 10 feet 0 inches. First, we convert feet into inches. Since 1 foot equals 12 inches, 10 times 12 equals 120 inches. Next, we divide the total height by the standard riser height of 7 inches. 120 divided by 7 equals 17.14. Since we cannot have a fraction of a step, we take 17 risers. Now, to get the exact riser height, we divide the total height by 17. 120 divided by 17 equals 7.05 inches. So, the final number of steps required is 17, and each riser height will be approximately 7.05 inches, which is within the acceptable range. Number of risers equals number of steps. Number of treads equals risers 1. Then treads equals 16. In this slide, we are discussing the angle of a staircase, also called the stair slope. The staircase angle is the angle formed between the stair slope and the floor level. This angle determines how comfortable and safe the staircase will be. For residential buildings, the standard staircase angle ranges between 30 degrees to 37 degrees. The ideal angle is approximately 32 degrees to 35 degrees, because this range provides comfortable walking and proper safety. If the angle is less than 30 degrees, the staircase becomes too long and occupies more space. If the angle is more than 37 degrees, the staircase becomes too steep, making it uncomfortable and unsafe to use. Therefore, maintaining the correct stair angle is very important in staircase design. In this slide, instead of calculating using the formula, we are using a quick reference guide for staircase angle. When the riser is 7 inches and the tread is 10 inches, the angle is approximately 35 degrees, which is comfortable. If the riser is 7 inches and the tread is 11 inches, the angle becomes about 32 degrees, which is ideal for residential buildings. When the riser is 6.5 inches and the tread is 11 inches, the angle is around 30 degrees, which is still comfortable but makes the staircase slightly longer. However, if the riser is 7.5 inches and the tread is 9 inches, the angle becomes 40 degrees, which is steep and not recommended for residential use. So, this table acts as a quick design guide to select proper riser and tread dimensions to maintain a safe and comfortable stair angle. In this slide, we are learning how to calculate risers for U-shape and L-shape staircases. Step 1 is to find the total floor-to-floor height. For example, if the floor height is 10 feet 0 inches, we convert it into inches. 10 feet equals 120 inches. Now, we divide 120 inches by the standard riser height of 7 inches. 120 divided by 7 equals 17.14. So, we take 17 risers, with each riser approximately 7 inches high. Step 2 is to divide these risers into flights. In an L-shaped staircase, the steps are divided into 2 flights with a landing in between. For example, 8 risers in the first flight and 8 risers in the second flight, with 1 riser adjusted at the landing level if required. Similarly, in a U-shaped staircase, the risers are divided into 2 opposite flights with a landing in between. The important point to remember is that the method of calculating risers is the same for straight, L-shape, and U-shaped staircases. Only the arrangement and direction of flights change. To conclude, staircase design is not just about connecting 2 floors, but about ensuring safety, comfort, and proper proportion. We learned how to calculate the number of steps using floor height and riser height. We also understood the importance of maintaining a standard riser size and a comfortable stair angle between 30 degrees and 37 degrees. By selecting the correct riser, tread, and slope, we can design a staircase that is both functional and safe for residential buildings. Therefore, proper calculation and standard measurements play a very important role in staircase planning.